Good afternoon. Thank you for attending. In this session, we will provide high-level suggestions for addressing some of your critical issues. It will take approximately 30 minutes. Please feel free to interrupt and raise questions at any time. And we will also have some Q&A at the end of the presentation. So let's quickly recap the background and the challenges you are facing. These issues and symptoms are typical and sometimes inevitable at some stage of your business during its fast expansion. One thing we should look into more closely, however, is that all the queries sent by apps are HTTP posts, which means all of them are dynamic. We need to rethink these HTTP posts seriously. Most mobile apps download far more data than they uploaded. Networks are designed leaning towards download capacity versus upload capacity. So I assume a large portion of the HTTP posts are actually for fetching data. If that is wrong, please do let me know. And if that is correct, then I suggest you change some of those HTTP posts. Firstly, use HTTP GET to fetch data instead of HTTP POST. This enables caching by CDN, and it may significantly reduce the network traffic. Using SSL encryption can protect your contents, including the query string in the URL. Secondly, you may use WebSocket protocol to push content updates from the server side rather than constantly pull from the client side. This may greatly reduce the number of requests between the client and the server. To boost your network, Amazon Road 53 plus Amazon CloudFront is the best choice. Amazon CloudFront is a global content delivery network managed by Amazon with over 410 pubs in over 90 cities across 48 countries, consisting of 3 layers of caching: the edge pub, regional pub, and the central pub. Furthermore, the origin shield optimizes cache hit ratio and collapses requests across regions. Even for dynamic queries that cannot be cached, it is still very useful because it allows the requests to be routed to the nearest edge pub and transfer data by Amazon's backbone network instead of by the public internet. And then connection establishment between apps and edges is also much faster than that between apps and the servers in California through the public internet. Amazon CloudFront also provides the CloudFront function and the Lambda at Edge services to process your requests locally. So in many cases, it can directly respond to your dynamic requests from the edge. Assume 6 busy hours a day for 30% of 1 terabyte data from Southeast Asia. The requested backbone upload capacity is within 15 megabytes per second, and you can send this data back to the servers in California through the backbone network with no pressure. Note that if you do not make some change to your HTTP post requests and all the requests are still through HTTP, through the post, and then the outbound data cannot be cached by Amazon CloudFront, that's a great degradation to its performance. On the network side, CDN is critical for caching contents and shorter the connection latency. And on the server side, you may use multi-tiered caching to improve your system performance and the robustness. APIs act as the front door of applications to access business logics and data. Using Amazon API Gateway, you can create RESTful APIs and WebSocket APIs that enable real-time two-way communications. The API Gateway handles all the tasks involved in accepting and processing up to hundreds of thousands of concurrent API calls, providing traffic control, authorization and access control, and throttling, monitoring, and API version management. Elastic load balancing, it automatically distributes your incoming traffic across multiple targets in one or more availability zones. It monitors the health of its registered targets and routes traffic only to the healthy targets. Database-related caching tools. By using Amazon RDS proxy, you can allow your applications to pool and share database connections. RDS proxy makes applications more resilient to database failures by automatically connecting to a standby DB instance while preserving application connections in case a database instance failed. If you using DynamoDB, which is highly recommended for storing key value pair contents or document data, you should use the DynamoDB accelerator or DAC because it can deliver up to a 10 times performance improvement at millions of requests per second. Depending on your application implementations, you can also use Elastic Cache to accelerate applications and data performances, or even as a primary data store for use cases that don't require durability at all. For inter-service messaging caching, Amazon Simple Queue Service (SQS) lets you send, store, and retrieve messages between software components at any volume. Illustrated here, there is one SQS for caching your outbound SMS and another one for caching emails. For Lambda functions, you may leverage Lambda local environment reuse to communicate between contexts. You may choose to onboard one or more services or techniques discussed here for data caching for your system. And the best part is that all these services are serverless, meaning you can focus on your customer logic and application code, offloading infrastructure management, resilience, scaling, etc., with a pay-for-use building mode. Here are some solutions to grow your system much faster. Use API Gateway for API creation, lifecycle management, and resilience. It makes it easier for developers to create, publish, maintain, monitor, and secure APIs at any scale. Elastic load balancing automatically scales as your incoming traffic changes over time. AWS Autoscale monitors your applications and automatically adjusts the capacity to maintain steady, predictable performances at the lowest possible cost. AWS provides bunches of DevOps tools and services, smoothly working with a vast range of AWS services and third-party services, among which the AWS CloudFormation is the basic automation tool to enable the infrastructure as code. It simplifies provisioning and managing infrastructure, deploying application code, automation software release, and monitoring. The AWS CDK, illustrated on the right, allows you to customize, share, and reuse constructs of cloud components. For the CI/CD lifecycle, you can use AWS Code Pipeline, Code Build, Code Deploy, and Code Store. And for mobile app development, AWS Amplify allows you to build full-stack mobile apps much faster, and it was built to integrate user experiences across multiple platforms environments, including web browsers, iOS, Android. For mobile device testing, AWS Device Farm lets you run automated tests for your mobile apps across an extensive range of real mobile devices hosted by Amazon without having to purchase, provision, and manage them by yourself. Serverless applications on the AWS platform starts with AWS Lambda, an event-driven compute service natively integrated with over 200 AWS services and SaaS applications. You may always consider using AWS Lambda when you are building your data process logic on the AWS cloud. The main features of AWS Cloud Lambda are listed here. The highlighted parts are common features for most of the AWS Serverless cloud services. Completely automated, built-in fault tolerance, auto-scaling, fine-grained performance, and seamless integration with S3 and databases, and integrated security mode, trust and integrity controls, and pay as you use. These features free you from the unlayered infrastructure and the implementation details with significant cost saving and let you focus on design solutions in the problem space. Cost optimization. AWS offers over 200 fully featured services, applications with lots of options, different pricing mode, furthermore, different combinations and orchestration of these services come out of different consumption patterns, making your cost control kind of difficult. One of the most common challenges with AWS costs is that traditional finance modes include signing off expenses before they occur. However, cloud costs are dynamic. Teams can hardly predict them, and budgets can be determined upfront. So, estimation and observation comes to be the first importance. AWS provides cost control tools for you. For estimation, you can use the price calculator to create cost estimations that match your use cases. It enables you to plan costs and the usage for a new scenario or determine the cost of using a new set of services, cloud instances, and pricing models. For observation, AWS Cost Explorer lets you visualize, understand, and manage your costs and usage over time. It also forecasts your future costs and usage for the next 12 months and provides recommendations for you to choose certain service instances to optimize the cost. AWS provides you a range of pricing models for computing, storage, and other resources. You should carefully choose the right pricing mode based on the nature of your workload. For instances such as EC2, RDS, Redshift, etc., you will use on-demand instances by default, which is the most convenient, but flexibility comes with cost. An alternative choice is using reserved instances. You commit to a predetermined amount of ongoing compute for either 1 year or 3 years. In return, you can receive a discount for that up to 72%. Another similar choice is to use the saving plans. Unlike reserved instances, you don't have to apply the commitments to selected types of instances in advance. You're just simply agreeing to spend the amount of money on overall EC2 or Lambda usage. You may use the recommendations provided by AWS Cost Explorer for choosing reserved instances and saving plans. Amazon EC2 support instance lets you take advantage of redundant resources in Amazon's resource pool, purchasing with a dynamic market price, which is lower than the on-demand instances up to 90%. This option is good for your stateless applications or services, such as web applications. You may consider using ADM-based instances or migrate to AWS Graviton2-based instances as well. Feedback from customers said that they saved 10% to 40% on computing costs by hosting on Graviton-based servers. For storage, Amazon S3 offers a range of storage classes designed for different use cases at different prices. S3 standard for general purpose storage of frequently accessed data. S3 intelligent tiering for data with unknown or changing access patterns. S3 standard infrequent access and S3 once-on infrequent access for the long-lived but less frequently accessed data, and S3 Glacier and Glacier Deep Archive for long-term archives and digital preservation. Amazon S3 offers capability to manage your data through its lifecycle. Once an S3 lifecycle policy is set, your data will automatically transfer to a different storage class without any change to your application. Choosing the right S3 storage class for your data lake can save you a lot. All AWS customers benefit from the automatic protections of AWS Shield Standard at low additional charge. AWS Shield Standard defends against the most common, frequently occurred network and transport layer DDoS attack. When you use AWS Shield Standard with CloudFront and Road 53, you receive comprehensive availability protection against all known infrastructure attacks. For higher level of protection, you can subscribe to AWS Shield Advanced. It provides additional detection and mitigation against large and sophisticated DDoS attacks, near real-time visibility into attacks, and integration with AWS Web Application Firewall. It also gives you 24/7 access to the AWS Shield Response team and protect against DDoS-related spikes in your EC2, ELB, CloudFront, etc. You can use Amazon API Gateway as an entryway to applications running on EC2, Lambda, or elsewhere. By using API Gateway, you don't need your own servers for the API frontend, and you can obfuscate or hide other components of your applications, preventing them from being targeted by DDoS attacks. You access AWS services using logic entries called endpoints. The default service endpoints use public internet gateway for communication and could be risky. You should create gateway endpoints or interface endpoints to access AWS services securely. Finally, visibility and observation are very important for security and protection. You use AWS Firewall Manager to centrally configure and manage AWS Web Application Firewall, AWS Shield Advanced, and Amazon VPC Security Group rules across your account. AWS Security Hub gives you a comprehensive view of your high-priority security alerts and the compliance status across your AWS accounts, and you have a single place that aggregates, organizes, and prioritize your security alerts or findings from multiple AWS services. Here are the solutions for real-time user behavior analysis. For non-real-time analysis, we will use the report and big data analytics tools, which I will cover on the next page. In case you need to perform analytics on data in real time, for example, website clickstreams or location tracking, the real-time data can be published to a Kinesis data stream instance. After that, there are a couple of ways to proceed. You can use the Lambda function to process the stream, and you need to write the custom logic. You can use Kinesis Analytics to transfer and analyze streaming data, and it happens directly in the service. And you can use Kinesis Firehose to cache and transform your raw streaming data into formats like Apache Bucket and dynamically partition data without the need to build your own logic. And you may combine them to make your own data flow against your business logic. On the right-hand side, it demonstrates two data flows from one streaming data source. In the hot mode, data is ingested to the Kinesis Analytics to analyze and characterize user dynamics in real time. Then the result is sent to a Lambda function, which fans out and writes to the DynamoDB and sends email notifications via a simple notification service. On the other path, the cold mode, the raw streaming data is sent to a Kinesis data file who's cached there, transformed and compressed, and written to Amazon S3 in batch mode. The demonstrated here are a general pattern to process real-time streaming data. Kinesis data stream organizes data in shards, and the default quota for one single stream is 200 shards, with each has 1 megabyte per second inbound speed limitation, which means it can process 720 gigabytes of real-time data per hour. Easily support 1 terabyte per day usage data for your case. For large-scale data analytics, as in your case, you will need binary tree solutions for your different scenarios. First, Amazon Athena provides the easiest way to run ad hoc queries for data in S3 without the need to set up or manage any servers. Queries are based on the S3 data lake with the best effort. Second, Amazon Redshift. It is the AWS managed relational DB based on PostgreSQL, working as your data warehouse. It provides the fastest SQL query performance for enterprise reporting and business intelligence workloads, particularly those involving extremely complex SQL with multi-joins and subqueries. The third analytic service you need is Amazon EMR or Elastic MapReduce. It makes it simple to run highly distributed big data processing frameworks such as Hadoop, Spark, and Presto. Use AWS Systems Manager for auto operation management. It is a centralized operation hub, not only for AWS resources, but also for your on-prem resources in a hybrid cloud environment. Using AWS Systems Management automation capabilities, you can decrease the time to resolve critical incidents, reduce manual efforts, and improve your security posture at scale. Two examples of auto operation management are illustrated here. In the first one, a config rule triggered an event in the system manager, and that event automatically addressed some compliance issues through an operational work item or ops item in the ops center. And you can go to the ops center to view it, process it, and trigger a runbook to resolve it, or the runbook can be automatically triggered against the conditions. In the second demo, when an option needs to go through an approval process, the runbook can initiate a change request and send a notification message to the approver. After approval, it can be either automatically or manually triggered or scheduled in a time window and automatically execute using a specific role. The whole process is automated, fully visible, and auditable, and it fully integrates with your business processes. To conclude, let's put all pieces together and show you the network diagram and the workflow diagram of the recommended solution. This is really a standard deployment without anything special. We suggest that keeping your EC2 and DB instances stay in the California region you are using right now, with no change or redistribution. For one reason, the adoption of Amazon CloudFront and other optimizations we talked before should solve most of your network issues. For the second, the uplink traffic is relatively small at the peak time. And for the third, you may prefer to evolve your system gradually. Take the most important movements, see the efforts, and get some knowledge and experiences, and adjust your organization, maybe, right, and even your policies, etc., and then move on to the next. We also suggest deploying the system across multi-availability zone for high availability with load sharing. You may build your system with local resilience, and all the AWS services come with built-in fault tolerance and high availability, but there are chances that one zone can fail. At your scale, this may impact your business greatly, so it is recommended to distribute your system across different zones. The Elastic Load Balancer can distribute requests among zones. In case a zone is down, it can automatically quarantine it by redirecting all the traffic to the other availability zones. And you may want to super provision availability zones so that in case one or more zone is down, the remaining zone still can handle 100% of traffic. And this page demonstrates the main data flow for your business. It involves the most important AWS services for data ingestion, log processing, and analytics tasks, such as user behavior analysis, daily reports, data mining. The real situation can be more complex, but we are trying to set up a pattern here as the start point. The data source can be your application itself, the file system it uses, and your transactional database. For the data from directly the application, let's assume that it is the real-time streaming data. And for data in the file system, let's assume it is log data that can be processed in batch. And for data from the DB, let's assume that it's generated by routine backup or calculation of build cycle changes, user status change, etc. At the top, for the batch data from the file system, we use an SQS instance to cache it, and then send to a Lambda function instance to process, aggregating with some statistic data, for example, and write it back to S3. At the middle, data were directly dumped to S3. And at the below, for the real-time streaming data, as we illustrated previously, we can use Kinesis to process in two ways, real-time analytics and batch processing through a firehose. The learning data then can be categorized and transformed by AWS Glue job to store as catalog data for further usage. We can copy the data in the categorized zone to Amazon Redshift, your data warehouse. There, it can be used to generate your daily report. We can use Athena to query the catalog data in S3 directly, and we can use Amazon EMR, the Elastic MapReduce, to run process frameworks such as Hadoop, Spark, and Presto. And this concludes the presentation. Thank you. And now I'm ready for the questions.